let us take a look at our conclusion here. So please write down what you have learned and what your takeaways were. Where do you still need explanations and how do you get that clarification? And then let's go together through the entire lecture topic here. So let's remember that trusses are idealized structures here in mechanics and that we are dealing with hinged joints. So we have really hinged systems here and we connect those members. So I can check that off. I also know that only axial loads are really carried here, right? So axial loads is very important because that prevents shear forces from occurring and that also prevents moments from occurring. So therefore we're dealing only with normal forces, but we just call them axial forces in this case. And because we're dealing with axial forces, we can only deal with compression and tension in the members. So that needs to be clear as well. So please do not start to calculate moments or shear forces or anything similar to that. So then we also know how to cut each node, right? So we need to understand how to cut each node and then how to represent the member forces properly. So when we do that, and we also do that for only 2 unknowns at a time, right? So 2 unknowns, no more can be solved. Please check that. That is because we have the sum of the forces in X and the sum of the forces in Y, which we are talking about here. So please be aware of that. And most important is that you can solve these member forces by using the equilibrium conditions and then also draw the proper representation of the results. And if you can do all that, then you reach the goal of this lecture and all that's left for you is to practice your problems. Let's take a look at the practice problems. So here you see some of your homework problems and you see they are very straightforward truss systems. So for example, here you have a truss system that consists of really 7 truss members, but it's also almost symmetric. Be careful because your load case is not symmetric, but it's a simply supported system and that should be easy for you to solve. Here we have a simple system which actually has some zero force members. In fact, you may want to check if some of these systems don't have zero force members, but you will, even if you don't see that when you calculate them, you will find that, for example, this member here is a zero force member. And I wish you good luck with like explaining that or with determining that calculation wise. And this is true for some of these structures, not for all of them, but overall, they all can be solved with the problems we talked about. And I wish you good luck with that. And I see you for the next lecture when we talk about the method of sections.